Good morning, everyone. That's Christ in the morning. So we're just going to jump right straight to it. My name is Abiodun Sanni. I'm a football lover and a problem solving. I like problem solving. So that's one of my problems. Problem solving. Because if you give me a problem like this, I just keep thinking about it. I'm able to see. So I have that problem. So I don't like, as David has said, I'm a leader professional. Whatever it's here, I build data pipelines, I solve problems. I can do almost anything. Right? Just give me the problem, I'll figure out a way around it. So because I have a consulting background now, if you have worked in consulting, you know that they can just throw you anywhere. You don't know the kind of project you're going to work with tomorrow. You're like, Alpha, we have this project, please just come and handle it. You don't even know what the project is about. So that's just the way it is. So next slide. So one thing I would say first, not everything that I want works. Not everything I want works. So you should get that a lot with SQL. You have a business problem and just think everything in your head, like okay, blah 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 blah, you write it down. Get a result. You getting a result doesn't mean that it's working. You should have that at the back of your mind. So let's have that at the back of your mind. So the first thing is asking questions. It's very essential that you know how to ask good questions, because if you don't ask questions, you end up making assumptions. Like you think you know, but you actually do not know. So a good result is just as a result of a good question. So if you understand the problem and you ask good question that helps you to understand the problem better, then you know how to go about solving the problem. So a good question is one that we ask and we learn something new from what causes another question to be raised. Like if you ask a question and the person gives you an answer from there, you're like, okay, if you say this, okay, so what? You lead to another question and this is another question, then you end up getting your desired answer. While back question on the other hand is one that confirms what we already know, and maybe general knowledge, and it completely leads you to another thing that is even off the chart, and you kind of don't even have like an idea what you want to do or what you want to do next. So for example, you ask a question like, okay, you are working on a project and you're like, okay, you are told to build a dashboard on something, and they just like, okay, this is the database you need to work with and stuff like that. But then you are not the owner of the data. You don't have any idea what the data is about, but based on the way the tables are structured, the table name and stuff like that, and you just kind of make assumptions. You just ask something like this: can I use the transaction table for customer analysis or the marketing team? The kind of answer you're going to get for this question is like, okay, yes, no, right? But when you ask something like this, how can I leverage this transaction table for customer analysis for marketing team, or how can I leverage this database you have provided to generate this dashboard or stuff like that? Then you now see the kind of answer like, okay, use this table, blah blah blah. Use this table to do this. This is the table I want. Like, have like an open-minded question, and kind of leads you to ask another kind of question that makes you to like understand, that gives you direction of where you want to go. Another kind of question is, I guess you found the customer data analysis you suit for your team. This is also another kind of question that's very bad, because you typically don't get a kind of yes or no answer to this, like yes, I can, yes or no. So even though I might not be that comfortable with that, but at least to some extent that yes, like, but asking some question like this, what part of the customer analysis report is most important to your team, and how does it influence your business? And then you have like a general opinion or a more detailed opinion about even deep down to the inside level of the dashboard, and tells you, okay, I think this particular part of the dashboard helps you to understand so, helps you to do this, and you have like a more broader perspective of what the team is doing and how your dashboard is helping the business solve a particular solution, and how you can probably even improve the dashboard better to solve some specific problem. And another one is, do you find my service delivery of my team in your current project satisfactory? That's a bad question. Compared to what can you say about the service delivery of my team in your current project, and what are the area of improvements you would recommend? These are so what I'm saying is that let your questions give room for customers to express themselves, or your clients or your stakeholders should express themselves. Don't give them like a closed-ended question, yes or no, something like that. So, which is not going to be very good. All right. And next thing, identifying your data source. So, from asking your questions might lead you to able to identify your data source, because understanding your problem better is just the function of the sources, right? So, if there's a problem, probably you're doing your root cause analysis and stuff like that, you want to go to the source, definitely. Where is the source? Because it's the source that leads to whatever output that was generated, and probably there's a pulling on the dashboard and stuff like that. You have to go back to the source. So, are you able to identify data source? Are you even actually working with the right data source? If you are not working with the right data source, definitely you're not going to be getting the right output. So, identifying your data source is very essential. So, you can have data without information, but you cannot have information without data. Right? That makes sense. By Daniel K. Moran. So it's paramount that you're using the right data source for your analysis. This will ensure not just the quality of your analysis, but also avoid doing the same thing all over again. Because if what you're working on is not, you're working on something using the wrong, so you're working on something using the wrong tool, compared to you're working on something and you're using the right tool. So if you're working on something and using the wrong tool, definitely you are going to be getting the wrong result, or probably it's going to like take a whole lot of time. You're just going to be running around, it's going to waste a lot of time. But if you're using the right tool, definitely it's going to like save you a lot of stress, and you want to ensure that you want to save time, because it's very important. Time is important, because the time you spend to deliver information is very essential when it comes to data, because you want to make timely decisions. So the decision you want to, that is supposed to take like, okay, after 5 minutes you want to like make a decision, and the insight is just coming like after 30 minutes or whatever. So that decision is no longer valid. That's is already still. So the next is identifying the right data sources helps you to streamline your focus when having issues with the result of your analysis. So if you know if you are sure that you are working with the right data source, you just need to like figure out, okay, where is this coming from your data source. Okay, so what might have gone wrong somewhere, you'll be able to focus on it. But if you don't, you are not even sure the data source you are working on, you don't even know whether it's valid or not, then it leaves you for a lot of people like you don't even know where to start from. So it's very essential that you know that you are working with the right data source, and that is the function of you asking the right questions and asking questions. So you don't want to think that, okay, I think this question is stupid, why should I ask that? Where is the data? Sometimes you feel like, I don't think I should ask this question. Ask question, please. They might sound like, I don't think I should ask. Just ask, because if you don't ask, you end up wasting your time. So having the right data source gives you the confidence to perform your analysis and give better recommendations to the business problem. Next slide. So also, I think we should also spend time to validating the sources. So quality analysis is just, and it was resolved, but it was renamed to another table, right, perhaps. And perhaps it was an oversight when they give you like, okay, this is the table you should work with, and they gave you that old table and you start working with it and blah blah blah. And at the end of the day, like you realize that sorry, we are no longer using this table. But a little bit of background check will save you the time of like having to waste the time and working with one table whereby there is actually a new table that actually solves your problem. So for instance, one thing about, okay, I think next time will. So we want to check data duplication, so maybe data acquisition and or your current. And having a knowledge about data is very essential. Data literacy. So how do you get that? You get that through asking questions from the data owners. So you have the people that actually understand the data better than you. Even though you're a data engineer, you're a data analyst, you don't know the data. So you just want to make sure that you don't know the data, right? So the product team that owns data, understand the data better. You want to like, okay, what is this, what is that, and you have background knowledge of what you're working with. Check for data breakage, that is trend validation. So probably you just want to like, maybe you're working with data that has to do with time. You just do like maybe a daily trend between for the past 6 months or past 3 months. Look at the trend. So if there's no breakage, then you can be sure. Like for example, look at this trend, and it's like there's a break in here. It seems that there's something missing. I want like, okay, I think there's something on there. Can you please check? Maybe there's not something. Probably at some point, system was down and no data was recorded. So probably the backend sector whereby maybe the data has to do with their mobile platform, and maybe their mobile platform was down for like 3 days or something like that. That might be the cause for you. I want to be sure that is not what it is. So we want to confirm. I want to check for data inconsistency, talking about trailing white spaces, data mishandling, constraint ignorance, and lack of a defined schema. So for instance, this trailing white space also very important, and this data mishandling something. So when I talk about training white spaces, let me give you a scenario where you're working with data, and I'm looking at an example I want to give. So if you have in the context of a data, maybe a gender column, it has male, female and stuff like that. But then at some point, maybe data entry, you might have male and maybe there's a space in front of it. You will not know it, it's just going to appear as male, right? But then by the time you're doing like aggregation, it's going to come out clear that you just see male, you see another male, and you see female, and maybe another female in space. That's 4 categorization, we're supposed to be 2. And you will be looking at it like this. This thing is supposed to, when you're doing aggregation, you go by gender. It's supposed to be male, female, right? Just 2, and you're seeing 4. And like, it's male and female. I'm seeing this thing now. It will just come to your head. Like, there is trailing white space. So you see male space and ordinary male as 2 different entities. So you might want to check that and avoid falling into that trap. Date mishandling. This actually occur a lot when you have something like when you don't define your schema very well. So probably in a column, in a table that has a date value which is being defined as a variant character, you can have so many issues, and you don't want to have issues with date. I'm telling you don't want to have that issue. It's going to it's going to finish you. You don't want to have issues with it. So it's better when you're working with dates. You want to define your schema, like it has to be date. So if you want to enter something that is not date, you tell you I cannot enter this thing. That's one thing about string. String is just like a list in programming context. A list can take in anything. Put integer, take. Put string, take. Put anything you put, take. So when you define your column as string and what you're saying there is date, you can take Monday year Monday, anything you put, and when you're trying to work it with it as date, then you start having issues like this thing is not working. It won't work. So you want to also check that. Next slide, please. So who's checking the time for me?
I am.
Okay. Another thing is understanding the data model. Right? A poor model will generally use unexpected results. I'm telling you. And you want to be sure that you know what you're doing. You want to be sure that you know what you're doing. You don't make assumption that there's this thing that is common to data professional. when it has to do with join, you see one table here, you see one table here. You say, there's ID here, there's ID here. I'll join an ID. You don't want to be so confident that those tables are connected by those two things because it's the same name. ID here, ID here. Customer ID here, customer ID here. That might even be true, right? But then that table might not just be connected by one entity, it might be two or more entities. So you want to be sure that you know what you're doing. Next slide. So we have different kind of relationship, one-to-one, many-to-one, many-to-many. I'm talking about joins. Joins is not just based on one clause. Trust me. It's not join on this is equal to this. You can have a join whereby you can do where this is less or equals to this, where this is not equals to this, and you can use all combinations depending on the scenario, the kind of problem you're trying to solve. So there is more to joins. Have you seen it all? Definitely not. Just like so one-to-one has to do with when you have like one-to-one relationship, one entity here next to just one single entity here, right? One-to-many, one entity here can lead to many entities here. In this case scenario, probably you have like let's say student is linked to can take some more than one course. The student can take more than one course. So in that kind of relationship is many to one. You have many to many. In this case, I'm talking about scorers and matches. So in this case, this match ID. So a match, you can have a player score as many times as possible, and in this match ID, this matches table. So perhaps the structure of this match is that okay, this match ID it occurs like in two rows. It occurs as two rows. The home team first, then the away team first. But in some cases, you might have that white, like the home team is just one column and the away team is the second column. You can have this one, but this one in this case is like two rows. The home team as the first row, the away team as the second row. A match comprises of both the home and the away team. Okay, there's more to join. As I'm saying, this is a kind of select statement that does join between two tables, cities and cities. This is a self-join. Cities and itself, and you're joining on state is equal to the state of the duplicate table, right? And you are joining where population is less equal to the second population. So you can have depending on the kind of problem you want to solve. So it's not just join on this is equal to this. It's not just about that. And this is also an example, a more complicated one. This is a correlated subquery. So next one. So look before you leave. A cautious move is always a lifesaver. So look before you leave. It's talking about next time. So you use sample cases when you're working with problems. You want to be sure that you are doing the right thing and you're getting the right result. So for example, you are trying to work on a transaction table. You can just focus on one particular customer, right? Write your select statement like, okay, this is what I'm supposed to get. So using that particular data of that particular customer is going to be able to see the clear picture like, okay, I think this is for me. But before you now push your code to the whole population. Also, result validation, that will also help you in result validation. When you have a smaller sample to work with, you'll be able to see that, okay, this is what I'm supposed to get. If you are not getting the right thing, then you have to know how to tweak your code and get to that result. So talking about expectation and reality, this is what you expected, this is what the expectation is, but in reality your code this is what it's doing. Yeah. So next slide. You want to ensure that you guide yourself when you are working in a data environment, right? Generally. Right? So for instance, you are trying to perform like some operations on the database and stuff like that, maybe delete operation, update. I'm telling you, this has happened to me before. Update, I was so sure, update, set this, and I use case statement. And I perform the stuff like this, I check the data, I swear, I wish I do. So I just saw that I fucked up. Like, you want to be able to show that you want to guide yourself and you don't do it. So, for example, You can adapt CT approach for writing your query instead of using nested queries or not. You don't want to use nested query. If you write some very complex code and use nested query, you can have like 5 or 6 nested queries. Like 2 weeks after, if you come back to that code, you might also find it difficult to understand what you wrote. What the hell is this? So you want to use CT, which is a top-down approach. Use transactions. Transactions saves you a lot of saves your ass. Let me just put it that way. So you run update statement, you run delete statement, and you eventually find out this is not what I want to do. So you can easily what is it called? Roll back on that transaction and you go back to the former state. Also, you want to try as much as possible to avoid using Windows functions. Windows functions are good, but then it's very costly to use. So you want to try as much as possible to avoid using Windows functions in some cases. So, okay, I think that's all. Thank you for your time. Thank you for listening.
Okay. Can I take questions?
All right. So, if you have any questions that you want to ask me, please don't ask me. I'll have questions.
If you're shy to raise up your hand and talk, you can scan the code and ask a question on Slido. But then you can ask him your questions. Technical, non-technical, he will take it over.
I have a question. Sorry, I can't answer the question.
So are there any instances where using a subquery would be preferable as against having to write the CTE? You know what I mean? Are there instances where you just have to write the subquery to do what you need to do? Or at every point in time, you shouldn't just write the subquery?
Okay, that's a good question. Should we do one letter of the question or do one at a time? Okay, so there are some instances whereby you don't need to write CTE. When you know that the software you want to write is not just write one on top of each other. But when you're writing complex SQL queries, you know that this is going to be select from another select. Then sometimes you have to do you do a select as a join. Like you have a select statement that you want to join on. You're not joining on the table. You now put it together again without properly putting the CT. It's going to be very, very complicated. But some instances you don't actually need to write. It's just like maybe 2 selects. It's just 2 selects. When it's running more than 2 selects, you don't want to use nested queries. I usually use the word nested query because I don't subquery I use within a where clause or having clause. That's what I term as subquery. So for subqueries, it's fine. You have one select statement and you put one where clause and you can have like correlated, uncorrelated subquery, one table and single subquery. That's what I term as subquery. You don't use inside the where clause or within having clause. But when you have select inside another select, I call it nested queries. So you might use it interchangeably. So when you have nested queries that is no more than 2 selects, it's fine. You cannot want to use CTE and stuff like that. And if it is some instance whereby you are trying to, and some people do write something like this. You have 2 tables that you want to join, right? You want to write a query, and you need 2 tables. You are just doing the join. Maybe you are selecting some columns in table A and some columns in table B, and you try to like use CTE and say, select some columns in this table, then write another one. Select some column in this table, then doing the join. You shouldn't do that. You can just write this normal select and do the join, and just one single select to do that. So you should know when to just work with your normal select. If it's not too complicated, you should just work with your normal select. Yeah, thank you.
Okay. This will be the last question of this session now. If you have more questions, you can just put them on slide before the end of the session very soon.